Hi, I'm Jeff Beer, president of BDTI. BDTI is an independent technology analysis and engineering services company and also the founder of the Embedded Vision Alliance. I'm very pleased to be here today with Vin Ratford, who's Senior Vice President of Xilinx. Xilinx is BDTI's partner in launching the Embedded Vision Alliance. So Vin, first of all, tell me what's Xilinx's outlook on embedded vision applications?
Well, we're very excited about the embedded vision application landscape, which is emerging as we go out and talk to our customers. Xilinx is in a lot of end markets and a lot of applications, but one thing that's very, very clear is we think embedded vision is the killer app for the next generation of 28 nanometer FPGAs. And the reason for that is it requires tremendous amount of signal processing or embedded processing in general. It has to be done in real time, requires massive amounts of memory. And FPGAs, particularly at the 28 nanometer node, have crossed the tipping point in terms of their ability to integrate an entire processing system, offer extensive amounts of signal processing, as well as connectivity in a low-cost, low-power platform. So we think it's the killer app for 28 nanometer FPGAs, and we're very excited and investing a lot into it.
So you said low cost, low power, and people who are accustomed to FPGAs from 5 or 10 years ago may not think of them as low cost and low power. Just roughly speaking, set our expectation in an embedded vision application, 2-3 years out. What's the magnitude of the power consumption and the price of an FPGA that's powerful enough to address these applications?
Well, a lot of these applications have to fit in a very small form factor. They can't have any kind of active cooling, and typically have to fit within under about 2 watts of power consumption. Many of these applications are powered by batteries or by or as I said, are in a form factor that requires very little heat dissipation. So the magic numbers are under 2 watts, under $15 in terms of price point. And we'll have platforms that hit those targets, at our entry-level FPGA platform and also in our processing platform.
And those are coming in what time frame?
Well, we've already started shipping software to customers, and we are sampling devices now on the mid-range family of our 28 nanometer FPGAs, and we'll have all of our products sampling by the end of the year, by the end of this calendar year.
Now, on the earlier generation Xilinx products, do you have customers building or shipping vision products today with the existing Xilinx FPGAs?
Absolutely. Actually, we have been in vision applications for multiple generations. What has occurred with each successive generation is the price and the power consumption continues to come down, as well as the computational performance of the FPGA, whether it's in terms of DMIPS or whether it's in terms of gigaflops or whether it's in terms of gigabits per second of I/O bandwidth. All of those numbers keep getting better and better and better. So in our Spartan 3 products, we started to see the kind of the early wave of the first hint of a tsunami that was coming. And then when we got into the 45 and 40 nanometer family, that's when we started to see a lot more applications. We started to get design wins in automotive applications for vision systems. We started to get designed into video analytics applications. We started to get designed into broadcast cameras. And in all of those scenarios, we were basically a companionship sitting alongside of a discrete processor. Mm-hmm. And with the 28 nanometer families now, it's possible to basically integrate both of those computational elements together.
Now, is Xilinx going out and evangelizing, hey, look, our products are great for embedded vision to customers, or are you going out and finding the customers have already figured this out and they're kind of pulling you along and saying, hey, we need more integrated chips, we need more IP blocks, we need other elements to enable us to do what we've already figured out makes sense?
It's a combination of the two. I mean, the reality is that in all new application domains, you always have early adopters that drag you kind of kicking and screaming into this new range of applications. And those customers were really the ones that started working with our Spartan 3 and then our Spartan 6 products, because they had, at Spartan 6 we started to put a lot more DSP performance into the family. Mm-hmm. And those customers typically bring their own IP. They've got the hardware, software, co-design expertise in the organization. They tend to be market leaders, so they tend to be innovators. And I would say that's been the kind of the early dynamic that has gotten us to the point where we now believe we have enough IP in our portfolio from a video perspective. We have enough computational performance. And the big challenge at this point is really trying to market the early successes, the early design win successes, more broadly, and then finding ways to move into adjacent applications. And so the Embedded Vision Alliance is clearly a way to do that and to be able to reach more customers, educate them on the possibilities, and continue to work on the challenges related to integrating all these elements together in an easier to use platform.
So in addition to education, making people aware of the possibilities, and in addition to continuing to turn the crank of delivering more powerful, more integrated chips at lower cost and lower power, are there other things specific to embedded vision applications that Xilinx needs to do to enable a large number of customers on a diverse set of applications to use your chips for vision applications?
Yeah, I think there are actually two major areas where we need to invest and collaborate. One is in developing a more robust ecosystem of IP partners and service companies that can actually help companies that have a great idea actually implement some of those ideas in silicon. Because there's still a need for hardware design expertise to really unlock the potential of the kind of platforms we're talking about. And not every company has that. So I see it as an opportunity for companies to join the Embedded Vision Alliance and learn about this and develop a business around these kind of killer applications. I think it's rich, fertile ground for innovation and for entrepreneurship. So that's one area, and we are investing in helping develop companies' expertise in this area. We've already got a number of partners in the automotive and the ISM space, and we're pretty excited about expanding that, but we need more of that. The other major area is in terms of improving the level of design abstraction so that customers can operate more effectively in a software-centric world and not have to require hardware expertise to get some of these algorithms and some of these applications into the marketplace. And even if they can, not being able to make modifications and extensions to the application without having to bring a hardware team back in to help them do that. So I think, obviously, we acquired a company rather recently called AutoESL, which has some promising technology to raise the design abstraction from RTL to C. If we can get to the day when everybody can develop killer applications in C, then we'll have many, many more potential users, many, many more potential applications. But it will still require an ecosystem to support it. So it'll take investments in both of those areas, and Xilinx is investing heavily.
Now, you mentioned ISM. What is that?
Industrial, scientific, and medical. It's a market of markets and represents a set of applications within those markets in which the ability to have ubiquitously connected devices that operate on a set of sensors, including cameras and other kind of sensors, and be able to process and execute command and control decisions in real time are really, really critical, whether it's machine vision systems or security systems or arthroscopic surgery or any one of a number of ways of being able to take the power of intelligent analytics in a vision system and be able to put that to useful useful business purpose.
And so this is, I think, one of the traditional aspects of FPGAs is that they get used in a really extraordinarily wide range of applications, and it sounds like these industrial, scientific, and medical segments are areas where you've got quite a diversity of customers and applications.
Yes, you do, and you don't have the kind of volumes that warrant investing in an ASIC or an ASSP. You've got a lot of connectivity standards and interfaces that are required to make the various islands of automation interoperate and work seamlessly together. You've got embedded processing that's required. You've got signal processing, and that plays very well to the attributes of FPGAs.
Now, when customers, system designers are building a vision-based application, and they're looking at a Xilinx FPGA as one possible platform, what are the other kinds of platforms they might be considering, and what are the 2 or 3 key differentiators that Xilinx believes are the things that really make it compelling to use an FPGA in those applications?
Well, there are general purpose embedded processors that have, rich set of peripherals, whether they're from Freescale or whether they're from TI or other companies. I think customers will always start with, if there's a chip on the shelf that meets my requirements and really has all of the capabilities that I need, and I don't need to implement anything in hardware, they'll start with that as a starting point. So I think there's plenty of opportunity landscape for other companies to offer solutions in this space. I think we'll see chipsets from companies. We already see that with TI, with the OMAP platform. The challenge will be finding the right combination of peripherals, processing performance, being able to fit it within the footprint and the both physical and the power footprint. I think customers will have a choice, and they will have these various platforms that they can use. But by necessity, any kind of fixed function hardwired platform requires that you make some trade-offs around what kind of applications will you service very well, and by definition, that means there are another set of applications you don't service as well. So one of the beauties of our Zynq platform is it is essentially an ASSP that has this built-in extensibility already integrated and available to the application developer. And so I think that moves us into the center of the radar screen in terms of being able to compete more effectively against those ASSP platforms. Those will continue to exist. My expectation is that they will continue to be targeted at markets and applications which generate a lot of volume and therefore may not serve some of these adjacent applications as well. So there's plenty of opportunity for us, and as we know, if customers have a choice of platforms, then that simply makes it easier to commit to a particular application and be able to know that you have a steady source of supply. So there'll be other choices, and I think that will be good.
So if I need the parallel processing compute capability that the FPGA can give me, and I need it for my particular algorithm that may be unique to my application, and or I need specific I/O interfaces integrated that may be unique to my application, and yet I need that in a low-cost, low-power, small package, then you think that the FPGA is going to be the winner there?
Well, I don't know that we'll be the winner all the time, but I think we'll be considered for applications we were never considered for before. And even if the customer can have their requirements met by today's ASSP, the question is, can they anticipate the variance of that platform? Because every customer starts out building a product, and then they inevitably end up building a family of products. And so they need scalability in terms of interfaces. They may need scalability in terms of performance. And a rifle shot ASSP may not give that to them. So I just want to be considered.
Well, I think it's going to be a big space with lots of opportunities. I think that's all we have time for today. Thank you very much, Vin, for the very interesting conversation. And I'd like to invite everybody in the Embedded Vision community to come to embedded-vision.com to learn more about the Embedded Vision Alliance and about how Xilinx addresses embedded vision applications.